Now let us start with polar vector. A polar vector is a vector which has a pole or a starting point. A vector which has a pole or starting point is called a polar vector. Its examples are velocity, acceleration, displacement, force, and so many things. The important points about polar vectors is that they have both magnitude and direction. The second thing that they follow is triangle law of vector addition. Triangle law of vector addition. They also follow cross product. So the only difference between polar vector and axial vector is that a polar vector follows triangle law of vector addition and axial vector do not follow triangle law of vector addition, while axial vector only follows cross product. So the most common vectors that we use in our physics are generally polar vectors. For example, velocity, acceleration, force, momentum, all these vectors are polar vectors. Now let us study representation of vectors. There can be so many ways in which vectors can be represented, but we will study only two methods of representation. First method is geometrical method and second one is symbolic method or mathematical method. So let us first study geometrical method. In geometrical method, we can write a vector is represented by an arrow, in which head of the arrow will give direction of vector and length of arrow will give magnitude. So here let us consider this is an arrow, this is tail of arrow and this is head of arrow. The direction of head will give the direction of vector. Now the magnitude of vector is given by the length of this arrow. So let us say the length of this arrow be L. Length of this arrow be L. Now we can write length of this arrow will give magnitude of this vector. So here we can write length of this arrow is directly proportional to magnitude of vector. Now to understand this, let us take an example. Suppose if there are two arrows, one is this and one is this. This arrow be 5 centimeter and this arrow be, let us say, 15 centimeter. If this arrow is denoting 10 Newton, then we need to find out how much force is represented by the 15 centimeter arrow. So we need to find out F. So to solve this, we know that length of this arrow, here the quantity, here the magnitude of arrow is 4. So length of this arrow is directly proportional to F. So we can say that L1 by L2 is equal to F1 by F2. From here we can write F by 10 is equal to 15 by 5. Now we will get 5 and 15 will get cancelled, so we will get 3. From here we will get F is equals to 30 Newton. So this 15 centimeter arrow will represent 30 Newton of force. That length of the arrow is directly proportional to magnitude of vector. Now let us try to understand the symbolic representation of vector. If vector, this is a vector, and if this vector has tail at A and head at B, so symbolically this vector can be represented by A, B with an arrow over AB. Or if we represent this vector as vector A and we need to make a bar over A. So vector AB, or we can write it as vector A, or sometimes in books it is written like A where A is bold. So these are the three ways in which vectors are represented symbolically. Now to understand vectors completely, we first need to understand few important definitions in vectors. The first important definition in vector is angle between two vectors. Angle between two vectors. So angle between two vectors is the angle between their directions. Angle between vectors is the angle between their directions. This is a very simple definition of angle between two vectors. So vectors are simply a quantity which has magnitude as well as direction, and directions are taken in north, south, east and west in such a way. So if we want to find out the angle between two vectors, we need to find out the angle between their directions. Let us take an example. Suppose this is one vector and this is another vector. So this is vector, let us say be A, and this vector be B, and we need to find out the angle between two vectors. So it is clear that the direction of B is somewhere here and the direction of A is somewhere here, and the angle between their direction is this. So this is the angle between two vectors. So here this theta is the angle between two vectors A and B. We can understand it in another way also. If we join two vectors from tail to tail, so if we join two vectors from tail to tail, let us say this vector be A and this vector be B. So the angle between two vectors A and B will be the angle between these two vectors when they join from tail to tail. So this is the angle theta, and this theta is the angle between vector A and B. Let us take some examples. Now let us consider these three examples, and in these three examples we need to find out angle between vector A and B in terms of theta. In the first example, if we join both the vectors from tail to tail, we will have this vector and this vector. So if this angle is, let us say, theta, in that case this angle is also equals to theta. So if this vector is A, this vector is B. Angle between vector A and B is theta. So here answer is theta. Now in this vector, if we join these two vectors from tail to tail, we will get this is vector A and this vector will be B. So, and we have already seen that this angle was theta. So this vector was A and this vector was B. So the angle between two vectors, this will be equals to phi minus theta. So here the answer will be phi minus of theta. Now in this case, if we join these two vectors from tail to tail, we will get this is vector A and this is vector B. And we have already seen that this angle is given as theta. So this angle is equals to phi minus theta. So the correct answer of angle between vector A and B will be phi minus theta. Now the second important definition is equal vectors. Equal vectors. So if two vectors are equal, then they have same magnitude as well as same direction. So we can write two vectors are equal when they have same magnitude and same direction. Now let us take two vectors. Suppose this is vector A and this is vector B. If both the vectors have same magnitude and the directions are same, that means vector A and B are equal vectors. Now a question will arise whether A and B are equal vectors or A and B are same vectors. Now what do I mean by this question is that whether A or B are two different but equal vectors, or A and B are exactly the same vector. Now to understand this, we try to express vectors in terms of words. Suppose if we want to express a force which is acting towards right, which has a magnitude of 30 Newton. How we will say this force in words? So we will say it is 30 Newton and towards right. Right. So if we are either writing this arrow in 30 Newton, or we are writing it in form of 30 Newton and towards right, that means they both are expressing the same vector. Now, if we want to draw this 30 Newton towards right, we can draw it here, 30 Newton. We can draw it here, 30 Newton. Why? Because 30 Newton is not just this arrow which is drawn on the paper. This vector is a physical quantity and we can draw it anywhere. So from here, we will have a very important point that vectors can be shifted parallelly in the space. That means if we have this vector, we can shift it to this place. So this vector and this vector, they both vectors are exactly same vector. So here we can write vectors can be shifted parallel in space. So if we shift a vector parallelly, in that case, the quantity or the vector quantity will not change. The thing that we were doing to calculate the angle between two vectors. So if we want to identify the angle between these two vectors. So let us say this is vector A and this is vector B. Now if we shift this vector B parallelly, so this vector we have shifted parallelly. This is vector A and this is vector B. So if we shift this vector B parallelly in the space and join with A from tail to tail, in this case, vector B will not change. So here, this is the way we can, this is the method we use to determine the angle between two vectors. Okay. Now the third important definition of vector is negative of a vector. So negative of vector is defined as a vector which has same magnitude but opposite direction. And negative of vector A is a vector which has same magnitude as that of A but opposite direction. So if this is the vector A, now another vector B which is negative of a vector is defined as a vector which has same magnitude but direction of this vector is opposite to that of A. If the direction of A is in this direction, that means the direction of B is in this direction. So this is vector B. Now here vector B is defined as negative of vector A. So this is negative of a vector. Now negative of vector does not mean negative magnitude. Here magnitude is positive but direction is negative. So these were the three important definitions in vectors. There are few more definitions. Let us say we have also defined zero vector or null vector. What is the meaning of zero vector? When we add a vector and its negative vector, we will get a null vector. So vector A plus of minus of vector A, we will get a null vector. This is the zero vector. Now zero vector has zero magnitude and arbitrary direction. So this has zero magnitude and arbitrary direction. So because addition of two vectors should always be vector, that's why we have defined the zero vector. And its whole purpose is to justify that when we add a vector and its negative, we will get a zero vector. Now there is another definition called as parallel or collinear vector. If two vectors are along the same line or parallel, we have already seen that vectors can be shifted parallelly in the space. So if these two vectors are parallel to each other, then they are also called as collinear vectors. So in vectors, collinearity is same as parallel vector. Now in vectors, we have also defined anti-parallel vectors. So what is the meaning of anti-parallel vectors? Two vectors which are collinear or parallel to each other but in opposite directions. If this two vector, this vector and this vector are parallel but they are acting in opposite direction. So they are called as anti-parallel vectors. For lines, we do not define anti-parallel lines. Why? Because lines do not have any direction. But in vectors, we have directions, so that's why we can define anti-parallel and parallel vectors.